derivative of e the power x sine x. So here we are going to apply the Leibnitz rule. So we are having two functions. Let me take this to be as first function and this to be as second function. So let fx equal to e the power x and gx equal to sine of x. Then first derivative of function fx is e the power x. Again, if you take the second derivative, you get e the power x. Third derivative is also e the power x, so on. And then the nth derivative also e the power x. Right? And now for gx equal to sine x, the first derivative is, yes, cos of x. Can I write this cos of x to be in another form, that is in terms of sine? Because I need all the terms in sine, right? So I can write this cos of x to be as sine of x plus pi by 2. Can I write like this? It's one and the same thing, right? Okay, so let me write this as sine of x plus pi by 2. Then to get the second derivative, so this is cos of x plus pi by 2. Again, I can write this cos of x plus pi by 2 in terms of sine. Sine of x plus pi by 2 plus pi by 2. The angle plus pi by 2, right? So it becomes x plus 2 pi by 2. So this is x plus twice of pi by 2. Yes? Similarly, we can get the third derivative as sine of x plus 3 times pi by 2. And so on. When we get the nth derivative, we reach sine of x plus n times pi by 2. So I'm getting all the terms in sine, right? Now let's use the Leibniz rule to get the nth derivative of this y. So by Leibniz rule, we have nth derivative of this function y to be equal to the nth derivative of the product of these two functions f and g. So that is equal to nc0, the nth derivative of first function, into gx plus nc1, n minus 1th derivative of first function, into first derivative of second function, plus nc2, the n minus second derivative of first function, into second derivative of second function. That is your g double dash x, right? So on ncn, f of x into the nth derivative of the second function, right? So it is nc0, and the derivative of first function is e the power x. And g of x, you are having sine of x, plus nc1. The n minus 1th derivative of first function is again e the power x. And g dash x, the first derivative of sine of x, we have got this to be sine of x plus pi by 2, right? Plus nc2. Again, n minus second derivative of first function, e the power x. And then the second derivative of gx, that is sine of x plus twice of pi by 2, plus so on. ncn, fx is e the power x, and nth derivative of gx is sine of x plus n times pi by 2. Is it fine? Okay? Alright. So nc0 is, how you calculate nc0? It is n factorial divided by 0 factorial n minus 0 factorial. So that is n factorial divided by n factorial. 0 factorial is 1. So this is 1 only, right? So nc0 is 1. So the first term becomes e the power x sine of x, plus what is nc1? Likewise, it is n factorial divided by 1 factorial and n minus 1 factorial. How can you write n factorial? It is n into n minus 1 factorial divided by 1 factorial into n minus 1 factorial. These two cancelled out and you get n. 1 factorial is 1. It is 1. 0 factorial and 1 factorial is 1. So nc1 is n. E the power x sine of x plus pi by 2. plus NC2 is n into n minus 1 divided by 2 factorial and the product of this. So I'm writing over here e the power x sine of x plus twice of pi by 2 up to so on. What is NCN? It is 1 only, and it is multiplied with e the power x sine of x plus n pi by 2. So this is the required nth derivative of y. So this is how, by using the Leibnitz rule, you can find the nth derivative of the product of two functions, right? Where y is product of e the power x and sine x. Fine? Okay. Now time for the thought of the day. The moment we stop trying to change others and start changing ourselves, things around us change. So instead of changing other people, just try to change yourself, right? And then automatically the things around you gets changed. With the change in you, the world around you itself gets changed. Alright, thank you, stay blessed.